Um, when marketing asked us to give a talk, Christian, Dale, and I said, only if we can be the last session on the last day. Thank you, marketing. Uh, no, but you obviously clearly are committed to security, and so we have, I think, a very interesting talk here. Just out of curiosity, how many of you have heard of BeyondCorp, Google's BeyondCorp story? Okay, there's some hands. For those of you who haven't, I'm sorry? You wouldn't come otherwise. That's how good the story is. Just for those of you who haven't heard of BeyondCorp, just a brief, and we'll get into the details here in a minute. This is a model, a security posture that Google started going through about 5 to 7 years ago, where we decided that the traditional model of security doesn't work for Google anymore, or in any company where the employees are scattered all over the world. VPNs are really not the way to answer those questions anymore. And so we'll talk about those in details. I'm Ameet. Christian will come up shortly, and then we have Dale from Vendasta, who's going to give us a lot of detail into what those guys did around the vision and how some of our tooling helps them get there. So that's in fact what we're talking about today. So I will quickly review the BeyondCorp stuff. We want to talk about some of the new products we've launched that would help customers get this vision delivered. So we'll talk about the identity-aware proxy, which you may have heard yesterday Urs talk about, and then Christian will talk through the security key. And then we want to leave a lot of time here for Dale to come up. I think he has a really interesting story about how Vendasta went through their change in security architecture, how they started implementing all this. And he likes questions, so he asked me explicitly to tell you to ask him lots of questions. So let's get started. I wanted to quickly review what BeyondCorp really means and what it means for you, the enterprise. We think of this as really context-aware secure access. So as we dive into that, let me start with a little bit of, and this is the way that Google did it. I think this is the way a lot of our customers are going through this model now. Right, the traditional model of security is what we call the wall-gardened approach. You have an employee who has to access exciting and interesting information and applications. We make them go through a VPN, right? No matter where they sit, we make them go through this tiresome, cumbersome, high-latency VPN, and then they can get access to all their applications. That model starts to break down, of course, as all of you know, when you start to introduce new users and new devices, right? So you introduce a contractor who's not necessarily a corporate employee, and potentially users that are coming in on mobile devices. Getting to those applications becomes harder and harder in that model, right? And when you do extend that model to fit for contractors and mobile devices, you find you have unintended consequences. Here you have a contractor who's supposed to be accessing the CRM system, but what they're in essence, you're allowing them to access everything, including the ERP system. So the walled garden sort of gets breached in this model. The evolution of what we're going through now sort of even more complicates this model. So you're now taking these applications that at least used to be behind a VPN, and now you're putting them in a cloud. Hopefully our cloud, since you're here, but many of you are putting them in many clouds, right? And so now the security model and access model starts to really break down how this world works. And then finally, what some of our leading customers are starting to do is start to move identity into the cloud as well. So there's no more on-prem AD, or it's becoming a secondary thing. Really now, identity lives in the cloud as well. So everything in essence is on the internet. You're in multiple places with multiple applications. Securing access to all of this world becomes very, very complicated. And so what that does is it introduces a whole set of new risk, right? There's many here, but I wanted to highlight some of the key ones. And I think this is the key takeaway slide, right? There are lots of things that we start to introduce as problems, and your vendors or you need to start introducing solutions for these problems. So the first one, we can start at the very beginning, right? The employee themselves, are they really who they say they are? Are they using the right credentials? Or somebody stolen those credentials? You think OTPs are safe, but those are just bearer tokens in essence, right? So somebody can come steal that and use that as well. So now you have to worry, is this the user that they say they are? Even if the user is who they say they are, if they're using a device that's compromised, they're using a personal device that has a lot of malware on it, what you're finding is that whatever data is accessed, the device has access to is now stolen data, right? And we'll talk about this in a bit more detail. I think a big and complicated part of all this is, of course, the network. One is your network encrypted? Is there a passive listener on there? Is there a man in the middle that's happening here? Can your network handle a DOS attack? Can it handle the load that needs to be there? You have uptime requirements. The network needs to be able to handle all of these things, right? And then we talked about it, as you move to the cloud, the new model is who can see these applications? Think about all the legacy lift and shift applications that you're moving to the cloud. They used to be safe behind the walls of a VPN. When you move them to the cloud, these legacy systems they don't have traditional access models, right? And now they're on the cloud. Are they accessible by anybody? And even if it's not a lift and shift application, applications that are custom built for the web, and actually Dale has a good point to this, I'm not going to steal his thunder, but you are very good at application logic, right? Your developer is very good at application logic. Is security necessarily a strong point for what that person does? And so we need to provide tools and things in that domain. So in essence, this is the high-level overview of where things start to go wrong. I didn't steal any thunder, right? Okay, good. So then what you're starting to see is let's get concrete about the things I've talked about, right? Like phishing, and I'll steal Christian's thunder here. Phishing becomes one of the largest attack vectors against your organization. Somebody can either just fake a website for you to go, your employee to go to, and enter their credentials, and that's it, or someone steals a token or cookie from your browser. All it takes is for those that token to be gone. It's a bearer token in essence now, and your account is phished. Everyone can access as you. The second one is malware, right? We see it in a lot of our customers. They're saying, oh, I had a backdoor I didn't even know about. Information just started leaking around. The man in the middle, think of an example. Actually, we had a customer who actually had this problem. During Heartbleed, somebody used Heartbleed to get searched from a supposedly protected server, and then just, even though the company thought the traffic was all encrypted in HTTPS, the tokens out, the keys out there now, people are listening man in the middle of those attacks, right? Or all of you know companies that have suffered through DOS attacks and have really suffered through all those things. The access policy, right? Access policy is in some points a choke point. You can start to really enforce access at these things, and we'll talk about what we can do with proxies. And of course, on the application side, it's very clear that you can have cross-site scripting attacks, you can have buffer overflows, all these types of things just end up leaking information out into the world. And so there are solutions to these problems, and there are lots of players in this space, but the vendors you go with need to provide those kinds of solutions, right? You have to have some sort of phishing-resistant auth, and we have a security key solution, which Christian will talk to in a moment here. But the idea should be that even if your username and password gets compromised, there are other factors, other second factors that are not compromisable, and that they'll protect access to your applications. Right? Device management is another key area where there's a lot of opportunity for protection here, and in two ways. If you think about it, one is in the configuration of your device. I'm enforcing that antivirus needs to be on this device. I need to make sure that antivirus is there, for example, or in the state of the device. Even if everything seems like it's set properly, is there a screen lock enabled? Is it in the right IP address? Those are the kinds of things where you need to be able to say, is this device, even if it's the right person on a corporate issued device, is the device in a good state before I allow access? The other part of this layered cake, if you will, is this idea that you have to have well-configured TLS. Managing the certs for all the TLS and everything is a hard job, and a lot of DevOps people are focused on keeping everything up, but not necessarily in managing these certs, protecting against DOS attacks and things like that. That needs to be. We need to make sure that we offer those solutions right out of the box for you. To me, the most interesting part of this talk, because it's one of the products I work on, is this idea that you have a proxy choke point that controls access, right? You can do a lot of things at this layer. The first thing you can do is you can start to take the context of the request. Is it coming from the right IP address? Is it coming from a safe device? Was the user strong auth in all of this? And say, yes, all these boxes check, let's allow access to go on here. But the proxy also does other things, right? It says, unlike a VPN model in the old world, you can say, now you can create more fine-grained access control over these places. The ERP app is out of bounds for me, the CRM app isn't. You can start to set those types of access policies as this proxy. And then, of course, you should always continuously be doing scans of your applications that are running in the cloud, making sure that there's no security vulnerabilities or anything that's gone wild out there. And so we envision a world where an administrator or a developer even can start to set very simplified policies that have very powerful consequences. An example of that is, for access to my ERP application, I only want members of my finance group to access this, right? No setting up VPNs, no making sure everybody's in the right place. Only members of my finance team should be able to have access. They should only be coming from corp devices. They should only be coming from in corp network or from the right geographies. I want to make sure they are who they say they are. And I want to make sure that's coming across a secure network. Those are very key policies I want to set. They should be check, 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 and you should be getting that out of the box. Google Cloud, especially after the announcements we made yesterday, if any of you saw Urs's talk, starts to offer a lot of solutions in this space, right? We introduced the identity-aware proxy. This is how we want to control access to applications by users' identities, right? From well-managed devices, watch the things that we're going to start to be doing here. We have an MDM solution already. We're going to offer richer solutions coming out shortly. From certain geographies, we want to make sure you can start to set policies that say corp network, not from sanctioned countries, from sanctioned countries, whatever it happens happens to be. We also want you to be able to use security key to be, and I know I'm not supposed to use the word unphishable, but very phishing resistant in accessing these applications. And the load balancer starts to provide a lot of things, right? It provides your TLS terminations. You want to be able to be hardened against these attacks. We offer solutions in these spaces. So a lot of these things we already provide here. You see the green and white boxes. What we're now introducing today, or actually yesterday, are two new parts of this chain, which we think gives you full coverage from end to end. And it's not that the journey ever ends, but now we think we have a lot of the boxes checked in total security. First is security key enforcement, and the second is identity-aware proxy. And so we'll talk about these two products briefly, and then we'll let Dale come up on afterwards and talk through how these things become actually useful in the wild. So I'll start with the identity-aware proxy and then hand it over to Christian. We call it IAP for its loving name, which is this part of the cycle. IAP is actually, the idea is very simple, but the value it provides is actually quite huge here. What we want to do is we want to give administrators and developers a way of configuring access controls by the people who are supposed to get access to those applications, right? You set users, you set the groups, you set the application they're supposed to reach to, and IAP enforces that access control. And the value here is that the devs can focus on the logic of their applications. We take care of all the other things that go along and around the security of that, and the administrator has full control in that world. Right, and so the experience is actually very simplified here, right? The administrator comes in. This is not actual policy syntax, but I wanted to use it to highlight how things work here, right? That you specify very clearly, members of the finance team can access my ERP application. That's it. It's as simple as that. And if any of you have seen the UI, you can see it's actually literally, you pick your application back end, you click the slider to activate, add your users, and you're up and running. It's that quick. So then the next day, the user actually comes along. Here comes Sarah. She's a member of the finance group. We can validate that. Actually, let me go back. She is, in fact, who she says she is. If we don't know who she is, we either send her back to your SSO or IDP to validate, or if it's a Google identity, we can send her into the Google identity system. She validates who she is. Once IAP does that check and says, yes, this is in fact Sarah, yes, she actually belongs to IAP, she actually belongs to the finance team. The next thing to do is, does she actually belong? Does she get access? IAP makes that check and says, yes, Sarah does in fact get access to the ERP application, and so she's in and she's running, and her life should go on very smoothly and easily. And we avoid the unintended access consequence, which is to say, but she hasn't been specified to access the CRM application, so she doesn't get access to the CRM application. It's as simple as that. And so that is, in essence, how we want to deliver IAP as the first step of the Beyond Corp vision to a lot of our customers that are running in the cloud. And I think as the second part of that, Christian will come up and talk about strong auth.
Hello, can you hear me? I'm on? Yep, hey. Hi everyone, I'm Christiaan Brand. Thanks, Ameet. I'm a product manager on the team at Google responsible for identity and security. And over the next couple of minutes, I really want to be focusing on secure user authentication. It's kind of the green part there, and how we can make sure that we're providing access in this model to the rightful user. So phishing, and I'm sure you all know exactly what phishing is, but just kind of to recap briefly, right? Phishing, an attack where a bad guy tricks a user into revealing their sensitive credentials, such as a username and a password, to the wrong website, accounted for 2/3 of the security incidents in 2015, according to a Verizon data breach report. Now, other than phishing, there's also other types of compromises. Passwords get compromised through reuse and interception. But the industry has a solution to this problem, right? The industry solution is multi-factor authentication. But the problem is that most of the multi-factor authentication solutions today rely on just another form of a password, the one-time password. And these really are just as trivially easy to phish as the user's standard password. And it doesn't really provide adequate protection for high-value accounts. So Google's research have also shown that even with all the user education going on and trying to warn users against phishing attacks and educate them, users will still fall for sophisticated phishing scams about half of the time. So this really is a systemic industry problem. So the mechanism we use at Google to achieve secure and phishing-resistant logins is based on a tiny piece of hardware we call the security key. You can see that on the right. So security keys form the basis of all authentication at Google. And if you use Google as your identity provider, you can also benefit from the same advanced protection. So let's briefly take a couple of moments here and go through how security keys really work and achieve this kind of elevated level of protection against phishing. So typically, if we look at what we're presenting here, right, there is a user. The user is trying to get access to a server. What normally happens in single-factor authentication world, a password gets sent from the left to the right, and that provides the user access to the resource, right? Pretty simple. So let's take a look at these next two slides, right? So we see something on the screen here, and I'm going to show you something else now. What changed? Does anyone have an idea what changed between these two slides? So let me call that out. The URL bar, right? That's phishing, right? So a user thinks they're on exactly the right site, they're going to input their credentials, but actually they're not really on the rightful website. And because users were kind of trained to look at the URL bar and things like that, but it's a lot of cognitive load for users, and most of the time they actually, like we said with our research, as proven, in about half of the time, users actually don't check for all these little details on the pages, and they still actually end up in these traps that a malicious or bad guy set for them, and they give away credentials to some phishing website. Now, one of the questions is, like, how did they get to this page in the first place? They didn't just mistype, right? So typically, and I'll show that in a second here, right? So typically, let's just talk through the phishing attack, right? Pretty simple. User enters password, password goes to bad guy sends password to rightful server, and bad guy is logged in, right? Pretty straightforward. So let's look at the next slide and how the user actually gets to this bad website in the first place. Well, normally that's kind of the model, right? Someone gets sent an email. The email looks like it's from the right party. The email might say something like, hey, you need to immediately change your password because someone tried to log into your account. The user would click on the link, unbeknowingly going to a phishing website because there's kind of, it's hard for the user to figure out whether this email really came from a trusted source. And there's other protections, of course, that's in place there, but at the bare basic level, users still kind of fall for these attacks. And that's kind of what we see. Like I said, about two-thirds of incidents in 2015 was as a result of this kind of attack. So we really need to do something to try and protect. So let's now look at security keys very briefly. So what we have is a user here on the left. The user is trying to sign in to a website. But in addition to only sending the password, something else happens here. The user typically has a security key. Security keys come in various different form factors. We have USB-based security keys. We've had them for a while. We now also have security keys that can be attached over NFC, near field communication, and Bluetooth, Bluetooth Low Energy, or BLE. So this security key on the left-hand side is with the user when they try to sign in. But this security key also contains a cryptographic key. It contains a unique private key. And there is an associated key at the server called the public key. And this kind of key pair got generated at some point in the past when the user registered their access for this specific service. So when their password was set up, they also registered their security key, which created these two key pairs. And the public key got sent to the server, and the private key got generated and stored on the token. So what happens now when the user tries to sign in, there is actually a password that goes down. Yes, that's your first factor. But there's also an additional signed, very important, cryptographic assertion that goes from the device to the server. And this cryptographic assertion has three very important components. So the first one is the promise that the user was physically present. And the way we promise that is by simply actually allowing the user to only generate an assertion, or the device to only generate an assertion when the button was clicked on the token. So you'll see with these security keys, they normally have a capacitive touch or a resistive touch or a physical button that need to be pressed. So at the point in time where you want to sign in, you need to physically press this button. So that's the promise that a user was present at the time of login at the machine. There is a server challenge, and this is kind of just part of the usual crypto response to protect against replay attacks. So the server sends a challenge to the device, and then the token responds back with that specific challenge, so in the response. But that's not the most important. The most important part of this, and the thing that really protects the user against phishing at this point, is that third line there that we kind of call the origin. So what happens is, when the user is on a specific website on the left-hand side here, or they're trying to access a certain service, the URI and the specific ETLD or the top-level domain, normally +1 in the case of the protocol that I have here. That's kind of specified by the specific request. But when the user is on a website, that website, for lack of a better term, that they're on actually gets incorporated in the digital signature that goes back to the server. So whatever the user is on the left-hand side gets incorporated into the signature and sent to the server. So if the user is on the rightful Google website, the Google server on the right-hand side will look at the signature and say, yep, that's what I expect. I expected the user to be on this specific website. That's what the signature presented to me, so I'll allow the user to sign in. So let's look at a phishing attack and how the security key in this case defeat the phishing attack that we saw a little earlier. So we have the same example. We've got the security key on the left. We have the corresponding public key on the right. We have the user trying to sign in. There is a phishing guy in the middle. User is on the wrong URL, as we can see. So what happens is we send the password, as per normal, over to the bad guy. The bad guy presents the crypto challenge to the user. The user clicks the button on their security key. An assertion gets generated, and the assertion that the bad guy gets at this point is obviously an assertion for the wrong website. So when the bad guy sends that assertion back to the rightful relying party, or the server, Google in this case, Google will look at that and say, hey, I don't expect this origin to be goggle.com, I'm Google. And at that point in time, they will simply reject the login. So it's really actually pretty straightforward if you kind of break it up like this. But the point is, the bad guy in the middle cannot tamper with that message block that gets sent from the client to the server because it's digitally signed using this private key that was generated out of band previously. So that's kind of the protocol in general, right? So pretty straightforward, but really pretty powerful. So now the question is, how does this technology apply to you? Well, we launched something we call security key enforcement about a month ago. We spoke about it earlier as well. And this really allows you as an administrator to enforce the use of security keys on certain groups of users or on certain organizational units. And by enforcing security keys, you make it really hard for bad guys to trick your users into falling for phishing scams, because even if the user is on a website that they shouldn't be on, the security key will generate a signature that your server will be able to detect as kind of fraudulent. And the other thing is security keys, of course, now supported on both desktop and mobile. We've had security key support for a while at Google. It was mainly around USB, but we now also have support on Android and iOS devices using NFC and Bluetooth protocols there. So then turning it on for a subset of users is really straightforward. Typically, it's a one-click event where you configure a two-step verification. You now have the option to say, hey, I want only security keys on these groups of users, and at that point, it'll be enforced. And all the other controls that goes together with this, onboarding users, taking them through the onboarding process, that's kind of all part and parcel of this kind of one-click event. So kind of as a last slide here, Stripe, one of our customers, has rolled out security key enforcement to all of their users, and they really believe that this is the perfect way to balance ease of use with increased account security across both desktop and mobile devices. So in summary, if you're worried about phishing, implement security key enforcement, and if you want controlled access to applications from the internet, implement identity-aware proxy. And with that, let me hand you over to Dale from Vendasta to talk about their implementation. Thank you.
Thank you. So hopefully these slide transitions work all right. So what I'm going to start off with is the obligatory marketing slide, but I think it's actually pretty relevant in this case to understand kind of who our customers are. And so the way we describe our business is we strive to be the #1 platform for selling digital solutions to small business or local business. And so if you want to think of who is the end user of our software, in a lot of cases it's a small business. And so this is not necessarily the high value target, but it is often also sometimes a person that's not super familiar with digital, because one of the things we're helping these people with is basically a digital transformation for them, to use the word that I guess we use here. What we're talking about is these guys used to buy Yellow Page ads, they used to buy all these traditional media and things like that, and they're looking for, I want customers basically in my store, or even better, some of them want customers on a website they don't have. So we essentially help to provide those tools to small business. And the way we do that is 85% of them purchase from an actual physical person that comes and calls on them. So we do this through resellers. So we have 1,700 brands that actually have salespeople that represent our software as like their brand, and then sell this to small business. And so for us, security, we consider it pretty important, and we consider security actually as like one of those features that it's like performance in a lot of ways, in that you don't really know it's a problem until you don't have it, and then you realize that that you actually did want performance or security. But unlike performance, if you don't deliver on security, it's pretty hard to actually regain trust, because if you have a slow website and you improve the performance, I mean, that's cool. Your users are probably okay with that. But if you lose all their data, or they use their bank password to log into your website and you lost it, that's kind of a big deal. And so I guess looking at this, when we read the Beyond Corp paper, like there's a couple of things that we thought were pretty striking on it, and it actually put you guys all said you'd heard of the Beyond Corp paper. Like, how many of you have actually read the Beyond Corp paper? So I don't see a ton of hands, but so I thought I would give like a couple of key pieces to the Beyond Corp paper. And I know that we talked earlier, Ameet was saying, like, we wanted to change a little bit about VPNs. And I mean, a lot of people are thinking, like, we're switching to cloud, so VPNs are too complicated. And so that's why we don't want to use VPNs. And I think that we're actually missing the point if that's what you're thinking. In terms of VPNs, the real issue is that on a VPN, it's more of a traditional, like, hard candy approach, I think they call it. And so the idea is, once you're on the network, you have access to everything. And so really what we're saying here is if your application design involves a VPN and it's for a new application, you're probably thinking about it wrong, because what you're basically saying is that I want to protect access to my entire application, and as long as I can do that, I'm going to be okay on security. And the way that I think that it's not in the Beyond Corp paper, but it was something I actually heard at DockerCon last year. I don't remember the speaker to give him credit, but what he said is that if you're thinking about preventing hackers, that you probably have already lost the game. Really, the answer you want to do is, like, when you get hacked, you want to minimize the damage, and you want to make sure that other things don't get hacked, because again, especially for us, in this picture that Ameet was showing before, I don't have control over their devices. I don't have control over a lot of stuff. So my goal is to actually make it so that if one of my users does actually get attacked, they don't get access to other users' data, so we can kind of minimize damage in that sort of way. And the other part is to make it harder, because again, it is unlikely that a nation state is choosing to attack one of our small business customers who runs a hardware shop in Delaware to access his information about his advertising or website. But at the same time, I don't want to trivialize the security problem either, because it still is important. And so for this, what we talk about is essentially a service proxy. And this is, Ameet was talking a little bit about this earlier in terms of, like, this is, we simplified a little bit in terms of saying that this is just IAP, and I'll get into that in a second. But, like, as an example, on our cloud that we run, our entire infrastructure is on Google Cloud. So I don't have an on-premise deployment, and I don't have another cloud. So those are not the reasons for me switching to this sort of a deployment. I control access to all of my microservices and my deployments through a service proxy. So that actually means that all of my services are publicly accessible. And so we don't have a VPN, we don't have special networks and things like that. They're all accessible this way. And so what I do is I use the multi-factor authentication specifically for access to GCP, and I do actually use service accounts, and I encrypt my traffic between all of my microservices. And so how many of you here have, like, a microservice architecture that you guys run? Like, we got a few hands. So quite a few probably have I guess I would show of hands how many people then have a monolith that they run. Okay, so then we've got about half the people here that run software. But anyways, in either case, what you have is you essentially, even in a monolith, it's likely that you have segments of your code that you're exposing. Maybe not as maybe you could be pedantic and you don't want to call it a microservice, but it is a separate piece of code. What we try to think of is that encrypting between those systems is actually really important, and trying to make sure that you have identities and everything else like that, again, because then if you suffer, like, a vulnerability or somebody gains access that they shouldn't, they can't just sit there and browse your whole network and see all your traffic. And so for us, the way we do that is we just make it publicly accessible. And so it's pretty, it makes everybody, all the engineers and everybody, think about, like, wait a minute, this is a public-facing service. I obviously have to encrypt things. I obviously need identity, and I can't trust that this is a VPN. So it leads to some better practices. And so what we actually said is, how do you consider yourselves, like, a fairly well-versed, like, understanding security? And then, is there anybody in the audience here that like sells security as their product, like, to other vendors? So like, one of the thing that we look at is like, we don't do that. And so for us, if you're a vendor of security, this solution I'm talking about, there's potentially, this is something that you don't necessarily want to do what I'm talking about. But what I say is I'm going to delegate identity to Google. It's a really hard problem, and when Christian was up here, you hear him talking about, we've got special keys of hardware, we've got signing, we're thinking about phishing, and then, I'm sitting in the audience and I'm like, this sounds great, but like, what happens if somebody hacks DNS? I don't know. Like, these are the kind of questions that I don't want to have my engineers really worrying about. And so what we actually do is we delegate our security to Google. And again, I don't delegate all of my security. So then what it becomes is I have to think about security. I do consider you need to be at some level an expert on security to understand, like, what is Google doing and am I comfortable with that? And making sure that, I'm covering the other stuff that Google doesn't. And so in terms of like the security, the words that I enjoy that Google gave out, and I don't think it's fair to give them credit for the naming, but we finally switched from authentication and authorization to identity and access management. I'm suspecting it's one of the other cloud vendors that came up with that, but I think the idea is, it's a really good distinction because they don't both start with auth. And so it makes it easier to actually have a conversation because you don't have that cognitive load of like, which one are we talking about? So I delegate identity to Google because it's probably the hardest part. And in terms of your security, it's one of the most important pieces because if I have a really great access management system that's very good at controlling whether Ameet has access to documents or whether I have access to documents, but the system actually has a really hard time determining whether it's me or Ameet accessing it, my security is kind of a waste of time, right? So like for us, we think that identity is one of the core parts that just because you get it right doesn't mean you're secure, but if you get it wrong, you're pretty much not secure. And so we consider that as something we choose Google as a partner for this, that to make these things more secure. And so in terms of what we also do is, at this point, my users, my small businesses, they log into my system. So I've got usernames and passwords, and so what we're doing is we're switching to single sign-on. And so that means like everybody here has probably used that in terms of like single sign-on is one of those terms that gets thrown around and oftentimes abused in terms of, but what it actually, I think the term, if you look it up, its original version, what it's talking about is sign in with Gmail. It would be an easy way to think about it, or sign in with Facebook, or sign in with GitHub, or something like that. What you're essentially saying is that I'm going to sign on with one provider, and I'm going to get access to multiple services. So the good part in this is that, again, we're trusting Google to manage all that extra work of checking devices, checking security keys, checking passwords, and then eventually at the end we say, when a request comes in, we say, is this guy who he says he is? And Google says, yeah, I'm pretty confident this is who he says he is. Now, there's a few issues that we can talk about this. I would like to have some more because right now what we have is, how many of you guys use G Suite? So we got a few people here. How many of you guys use two-factor with your G Suite? So we got a few people that do. One of the things that you'll find that G Suite does for us right now, which is kind of interesting, is it has this, it assigns the level of trust required to an actual user. And so what it's going to say is like, hey, Dale is a guy who has access to quite a few, top secret documents. And so we want to make sure he has two-factor. But then what that actually means for me is now when I want to, SSO into, Stack Overflow, I need two-factor. And so like one of the things we would like is the ability to say like, I can, as an application, say like what level of trust I care about, because and that could be either at an application level, like IAP talks about, or even within an app, because you could imagine on Google Docs, it's frustrating if I have to have like security keys and a bunch of other stuff when I want to read the social committee meeting minutes, and the same level of trust is required for other documents. So some of that stuff, I think there's some room to move forward, but specifically around making it easier for these users. And so when I was talking earlier about the service proxy, which is that IAP, one of the things that's important to see is that we actually use kind of a couple pieces here. But like a load balancer is obviously another important component if your service has like more than one computer, that's or VM or container or whatever that's going to be serving it. And so like a layer 7 load balancer plus IAP is actually, in terms of if you're reading the Beyond Core paper, that's kind of how we view what the service proxy in that picture is. And this is what we use in front of basically all of our services on Kubernetes that we run in GKE. And so this is what's implementing that particular piece, and I think I've got a beautiful animation here that the Google marketing guys put together. It's like, so this is what we were talking about earlier, and then boom, it breaks that first piece up into two. So this is, like you guys have all probably used the layer 7 load balancer. It's really not that bad, and I mean when Ameet comes up here and shows that you just like to type in a policy and it works out pretty well. This stuff is, it's actually pretty easy easy to get started with and add some pretty powerful rules to add this security. And then what Cloud Endpoints does for us is we implement our microservices using gRPC. And what you'll find is that a lot of our customers do not like or use gRPC, and for us, we don't really want to have to, we don't have to lower our performance or our expectations of our own APIs by implementing them all as JSON REST. And so what we do is we use Cloud Endpoints to provide a JSON gateway. It provides monitoring. There's a lot of great functionality that Cloud Endpoints provides, and it's just a sidecar running along with our pods. And so that's kind of what we offer there. And so then every single one of the requests that's coming in here, we've got an identity associated with it. We've got Cloud Endpoints here to manage some of the monitoring and the other things, and then our applications are left to manage the access. And so again, we have a coarse grain level from IAP, but we have, again, we can implement our own specific access requirements at the service levels. And so, like, I guess one of the things we look at here, sorry, I guess I've got the beautiful thing down here. We use these keys again to protect accounts at our office. Like as an example, I have access to delete GCP projects, and so it's for us we consider it important that I do use two-factor. Some of the stuff that I think what we were talking about earlier with the security keys, like this is great that they're and I know like a lot of people will say like you can't say the words unphishable, which I think is fair. I think we get into things like the security keys actually on these guys in the U2F standard. They actually support client certs in the way that we're talking about signing there, but you can actually get down to like a TLS level and do some of those things too. So it's pretty cool what some of these things support, and it's important to our business because again, it's not the small business that I have to necessarily protect at this level, but it's basically the people at my office that I need to make sure this sort of stuff happens. But obviously that only works if I can actually delegate login into my system for my users to Google. And so we've already done this. So what this means is if you're a user in any of my systems that has access to administrative functionality, we actually require you to have both a login into our system and a Google login. And so what it means is that I can manage admin access to my entire application through G Suite, because I can just like disable a G Suite account, and all of a sudden now you have no access to any more of the admin functions. And then in terms of what we actually see is really exciting is our ability to throw in this second factor. And the one thing that we lack right now as a part of this is when I get an identity, I have no ability to say that, hey, does this identity have two-factor on it? So it's kind of up to me to make sure that like I've implemented two-factor on my organization, and the functions that I want to be two-factor protected, that I've coordinated that. It would be really nice if, like, when an identity came in, Google could say, like, hey, here's the level of trust associated with this, so I didn't have to make sure that I've got it right in two different places. And so there's a whole bunch of different things that I think I want to summarize a couple. I want to make sure I didn't miss any of them here. But like the idea of using client certs specifically to simplify, I think people have talked about at one of the talks I was at, there was what version of the best practice for OAuth should we be following? And in some ways for us, like service to service is simplified if you just use client-based certs. In terms of I have a client cert that exists on one of these. Either it's protected in my service if it's a backend service, or maybe it's on my YubiKey or something like that. It's something that we would really like, and it's not something that's supported right now in terms of like if you're using a layer 7 load balancer, so you can't actually do that for some of these things. And then the other thing that kind of bothers us is like gRPC is not supported right now on the layer 7 load balancer. So while the picture up here is showing a layer 7 load balancer, we use that for our JSON gateways, and the gRPC stuff goes to a layer 4 load balancer. So that kind of stuff is something that we end up having to compromise in there. And then I guess some of the other stuff is we would like to see this ability to do more metadata about the identity, because right now it's just like I get an email address basically is what I get for an identity, and it would be nice to support things like we said, the metadata about like the level of trust, or even the case of again I'll call it a stacked identity, which is like I'm microservice 1 and I want to do this work on behalf of Dale. And I actually have both those pieces of information that could be helpful. And so those are some of the things I'm looking at in terms of our organization. And so again, what you're going to find is that the conclusions are actually very similar that we came to that Ameet talked about earlier, or was it Christiaan? I think it was Christiaan actually summarized it up. We've implemented security key enforcement internally. And we've implemented identity-aware proxy. And then what we've specifically done is we've moved to SSO for all of our identity internally. And our goal is over the coming year to start to roll more of that out to our customers by adding support for SSO logins and then eventually removing support for username and password-based logins so that we can delegate to trusted sources that have two-factor auth, such as GitHub or Google. And so for our end users, I guess we'll see like what the adoption rates are and see how many providers we end up having to go with to make sure we cover all the small businesses. But for internal, since we have G Suite and a large percentage of our resellers do too, it's likely that we will choose just Google to do our identity for that. So at this point, I figured I'd ask if there's any questions on some of this stuff. I find this stuff really exciting. I find it kind of interesting in terms of reading about all this stuff and how these standards around encryption work, and then not having to implement half of them because Google does it for us. But I guess there's a microphone here in the middle, so if anybody had any questions, they'd be appreciated.